Good morning, everyone. Welcome back. Thank you for joining us. We're going to get you through this Monday. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yep. And today my venue has changed just a little bit. I'm out in the garage, and because I have family here, and I did not want to disturb them this early in the morning. So here we go. Oh yeah, we're talking about aliens, which um, kind of fits my mission right now. So here we go.
Archived radio observations could open new frequencies to SETI. SETI is the Search for Extraterrestrial Intelligence, while showing that past searches covered millions more stars than previously estimated. A potential. So these are dishes that are aimed out into space, and the Earth rotates, right? So they're watching the whole heavens, and they're picking up radio signals.
Right.
All right. A potential extraterrestrial signal could be hiding in radio frequencies that modern searches for intelligent life have barely examined. Most radio SETI, Search for Extraterrestrial Intelligence, projects concentrate on frequencies from 1.4 to 1.66 gigahertz. Now, are aliens going to be conveniently talking in those bandwidths? I don't know. Astronomers call this region the water hole because it falls between the natural radio emissions of hydrogen and hydroxyl, which combine to form water. Okay. Would you like to know more?
This relatively quiet stretch of the spectrum has long seemed like a sensible meeting place for communication. Researchers reasoned that an advanced civilization might understand the importance of hydrogen and hydroxyl and choose those frequencies for both transmitting and listening. Okay.
New research, however, indicates that higher frequencies could open another path in the search for technological signals from distant civilizations. And you'd think with AI, they'd be able to search these, really fast. The work was recently presented at the Royal Astronomical Society's National Astronomy meeting in Birmingham, UK.
Okay. Louisa Mason, an astronomer and PhD researcher at the University of Manchester, conducted the first SETI survey with the Atacama Large Millimeter Submillimeter Array, or ALMA, as they're calling it here for short, in Chile. Instead of requesting fresh telescope time, she examined archived observations originally gathered for unrelated astronomical studies. Her search targeted narrowband radio signals, which could point to technology rather than naturally occurring processes in space.
Mason examined two narrow frequency windows in ALMA's Band 3 data. No candidate technosignatures, or alien signals, exceeded the survey's detection thresholds. The analysis covered only 4 archived ALMA observations, but Mason says it shows how high-frequency radio telescopes could contribute to future SETI programs.
The work also draws attention to a largely overlooked feature of radio astronomy. When a telescope observes one chosen agent, its field of view simultaneously includes many additional stars. Researchers have generally estimated that stellar bycatch, which is apparently the term that they use, with catalogs such as, is that Gaia? Mason instead applied the Besicon galactic model, to calculate the wider population of stars inside each observation, including objects that are too distant, faint, or difficult to identify reliably in available catalogs.
When she applied this approach to an earlier SETI survey containing more than 1,300 telescope pointings, the estimated number of stars covered rose from roughly 288,000. Now, that a star is like our sun. 288,000 suns out there. I mean, Heavenly Father's works are numberless. It's crazy. Yep. In the Gaia catalog, to more than 6.1 million in the galactic model. Oh my gosh.
Wow.
According to Mason, the result offers a more accurate estimate of how much of the Milky Way has already been examined for technosignatures.
Mason stresses that finding no signal does not rule out the existence of intelligent life. It means only that the study detected no candidate signal within the two small frequency ranges examined. She hopes the results will encourage SETI researchers to explore a broader portion of the radio spectrum while extracting more value from astronomical data that already exists. So,
I say we get AI involved. Plug it through,
yeah,
churn it through the system.
I'm surprised that they haven't done that. And maybe they have, they just not letting on to it. So, but yeah, this is pretty amazing. Those numbers, 288,000 and 6.1 million is, those are huge numbers.
Scott, do you think aliens are out there?
I think your aliens are right here.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Have a good day.